this yourself by just paging through it, but we do notice that the notes column has all data in all the rows except for one that is null. But let's pretend we don't know that right now, and we'll take a look at what we know and what we can find out about this table. So there's a query here to look at the indexes that we have available on that table. So I'm going to run that and take a quick look at what indexes we have. There's the clustered index. It's just clustered on the ID column. And actually, let me just run both of these at the same time so we can look at all of the columns and what we have indexes on. So in this case, the ID column is covered on the clustered index, and because that's in the clustered index, that ID is also going to be in all of our non-clustered indexes, even though it's not shown here. So we have this index that's called bad name for an index, and it includes the year and notes column, so that's the last two columns in the table. And then we have another index called department ID and year, which contains the department ID and revenue. So that's one that it was a bit of a confusing index there because the name doesn't really match what's in the index, but the column names show that all 5 columns represented in this table are covered by these 2 different indexes. So that makes me think is hopefully I can pull data back from those indexes and compare it to what's in the base table. And this next example, or what we're going to look at here, is selecting from the table revenue using the with index hint, and I'm going to select back ID, year, and notes, and that's coming from one of the non-clustered indexes, and you can see that we get notes back all the way through for 54 rows, and that row 31 that we looked at earlier that was null is actually showing something here in this specific case. We can then pull from the other index, the other non-clustered index, and look at the ID, department ID, and revenue, which is coming out of that one, and see that we get 54 rows back, and they look valid there, but let's do some checks. So in this specific corruption challenge, which was posted several weeks ago, Brent Ozar was one of the people that competed in it, and he submitted this as he phrased it as kind of a quick and dirty way of checking what's there to see if it's going to match. Now, in this specific case, there are ways to, if one revenue was a negative that offset another one, or a department ID, this could not be entirely accurate, but it's just a quick way to check and see if we're even close. So we're going to run that and see that the sum of all the department IDs is 108 for both using the clustered index and using the non-clustered index. And the sum of all of the revenue numbers in using the clustered index and the non-clustered index comes out to be the same here as well. So that gives us the assumption that we're probably the same on all of the rows there. And the next one we're going to look at here is comparing year and the sum of the length of the notes column. And the year numbers come out between the clustered index and the non-clustered index to be the same as the sum. However, the sum on the notes column comes out as different, and we saw that with that one null field that was there. But what we want to look at next is what's really different between the notes columns between the clustered index and the non-clustered index. So here I'm going to be selecting the ID, the notes from the non-clustered index, and the notes from the clustered index. And from the revenue table with the bad name for an index index hint, and then outer joining revenue, the same table, self-join using the index as the clustered ID index. And then I'm going to return where the data is different between the 2 notes columns, and I had to wrap them in the is null because if the value is null, it doesn't return correctly there. So if we run that, we can see that the notes column on all of the rows in the table, comparing the clustered table to the non-clustered table, are the same except for this one that has this non-clustered index here. Or in the non-clustered index, it has the actual data value that looks like this. In the clustered index, it's null. So what if we can just update that bad row? And I've wrapped this in a transaction so that if it goes bad or doesn't do what we want it to do, we can undo it. So I've wrapped it in a transaction. I'm going to say update revenue set notes equal to test, where the ID equals 31. And then I'm going to roll it back if it actually works. So when we run this, you get a severe error that occurred on the current command, which shows that Because of the corruption at this point, we are unable to modify the notes column at that point. We can't just update it and override it with something that that somehow straightens out the corruption there. So the next thing we've done here is we've got a query that looks at the non-clustered index or actually it looks at both of the non-clustered indexes and brings back all of the data that we can and formats it in the right order to match up with the original table. So if we run this query here, we now see that pulling data only from those non-clustered indexes, we're able to pull back all of the data that's in the original table, including row 31, which has that corrupt data in it. Okay, so at this point what I want to do is I want to save that data off somewhere so that we can then go and do work to fix the corruption. So I'm going to create a table called revenue save that has all the same columns as the original revenue table. However, the ID is not a primary key because I'm just inserting values that already exist there. I'm going to then insert into that table everything out of that select statement that we just tried to bring the data back from the non-clustered indexes. I'm going to then select from the revenue save table and confirm that we have all 54 rows. Okay, but at this point, how do we know what's missing or what's different? Well, we could go through and jump back up, jump down here, and I've got a query that will show us what's different between the two tables. But when we run it at this point, it shows that the first 5 columns, 1, 2, 3, 4, 5, the first 5 columns that come back are from the corrupt original table. The second 5 columns that come back are all from the new table that we've just created to hold the data. So we can see that everything else between those two tables matches identically when we look at all of the different columns there. So let's try a few things here. We've got the check table with the repair rebuild. Let's see if we can get, and we're going to wrap this in a transaction so we can undo it if we need to. So I'll begin the transaction. I'll then run check table on revenue with the repair rebuild and see if I can fix it. And here we get error messages that says the repair level caused this repair to be bypassed. So that's SQL Server's way of saying repair rebuild isn't going to fix this corruption. And then we've got a number of other messages that say repairing this error requires other errors to be corrected first. Okay, so let's look at the table and we can see that we still, in the original table, we still have 54 rows shown down in the corner here, and row 31 is still corrupt. So let's roll back that transaction. Even though it didn't do anything, we'll unlock the transaction. Now let's take a look at repair allowed data loss. So I'm going to begin a transaction so we can undo it if we need to. So this check table with repair allowed data loss, it's going to go through and scan that table, and if there's any corruption encountered, it's going to throw out the pages that are there and basically free up the pages, and whatever rows existed in those pages that were corrupt will be lost at that point. So we'll run this, and again, keeping in mind it's not a very big table, so as it goes through it, it did it pretty quickly, and it says the first error that it encountered has been repaired, the next one has been repaired, and all the way through all of the error messages have been repaired, and a couple of indexes happen to get rebuilt because of changes in the base table there, or in the clustered index. And when it's all done, it points out that that everything at that point has been corrected. So let's take a look at what's in the revenue table. So at this point, we select star from revenue. Hey, no problem. Table comes back. I don't see that null in there, but there's only 27 rows. There was, I think, 54 before. So what happened was running that repair allowed data loss dropped a data page that happened to contain about half of the table. It's not a very big table. So let's take a look at what's missing. Here I'm going to select from our revenue save table everything that's not in our revenue table using the select or the except statement there. And I can see at this point that IDs 28, paging down all the way through 54, have been returned as the things that are missing. So I could roll this back, but at this point I'm just going to commit the transaction because I know I can go patch up all the missing data at this point. I then run DBC check table just to make sure that we're clean. Yep, no error messages brought back at that point. And so I'm going to check the entire database, and it has no error messages either at that point, so we are clean. But back to the revenue table, we're missing about half the rows there. And if we run our difference query that we ran earlier, it shows us that the first 5 columns come from the revenue table, the second come from the revenue save table, that there are 27 rows that are missing. So let's just put those back into the revenue table. And the way we're going to do that is to set identity insert for revenue on, because we can't just insert them with the identity value there. So we're going to allow it to overwrite the identity values, or put in identity values without automatically generating the next one. We're going to insert into revenue with these columns everything from the revenue save table where the ID is not in the revenue table today, and then we're going to set identity insert off. So you run that, 27 rows go back into the table. We check out how many rows are in revenue. There are 54 rows in revenue, and if we page down to row 31, we can now see that the notes column has been restored. It's no longer null. And we'll check for differences. When we run the difference script, every row in the revenue table now matches every row in the revenue save table. Okay, so we've cleaned it up at this point. Else goes wrong, we're at least able to get back to the state quickly. So the backup's been run, 320 pages backed up, and the corruption has now been solved on the first example here. I'm going to flip back over to the PowerPoint and ask if anybody has any questions at this point about what we did to get the corruption solved in that first example.
There's just a question asking, how do you find out if a non-clustered index has corruption?
Oh, great question. So the question is, how do we find out if a non-clustered index has corruption? I don't have an example of that here, but if I jump back to the beginning and restore the corrupt database, when we look at the error messages here, it's referring to index ID of 1 as where the corruption is. And in this specific case, that's the clustered index. Actually, index ID of 1 is always the clustered index. But if we had a non-clustered index, it would be showing up with a different number. And I think on this example, the index IDs were 8 and 9. So it would show a value of 8 or 9, and we could just have dropped that index and recreated it. Any other questions before we move on to the next example?
What's the 2 in the DBCC page? I lost it. Hold on. You did DBCC page 1, 158, 2. What's the 2 stand for?
What you're given in this case is you have 2 backups. The latest is a backup of the current corrupt database that somebody ran the full BAK after the corruption was known about. And then the 2 days ago backup is the only other backup file available, and it doesn't contain any corruption. Now, somehow in this case we can say that somewhere along the way log files were lost if they were being run, but all we've got is these 2 BAK files. So this one, we're going to take a look at Corruption Challenge 2, and when we select star from revenue, it shows us that, well, we can't, previously in the first example, we were able to select everything out of the table, and it just showed us nulls where the corruption was, but in this case, it's more serious. When we try and select from the table, we get these error messages. and let's jump into it. So the things to think about is, what would you do first? If my work makes something worse, how can I undo what I try? What can I do to determine what's corrupt? And what can I do to recover the missing data caused by the corruption? So let's take a look at this and see what we can do with the second example. So here we have the two BAK files. So first I'm going to just look at the restore file list only and see what's in both of those BAK files. Okay, they look similar on the file names and similar on the groups and all that, and similar on the sizes. However, the data is indeed different inside of them. So let's take a look at restoring the latest backup. So first I want to think about, well, if something goes bad in everything I'm trying here, how can I undo that? Well, the way I'm going to undo it is I'm just going to go back to these backups and try it again. So I'm going to restore that latest backup. It upgraded the database to the current version, and it put it in the right directories that I have available to work. So I'm going to use the new database. I'm then going to do a check DB like we did before, and again with the no info messages speeds it up a little bit, and then it only shows you the errors. And we can see that yes, indeed, we have corruption in our clustered index again, and it's at page 244 and maybe 245 depending on what's being shown here. So I'm going to, but we also saw here that it's in the revenue table again, so that pesky revenue table. We'll check table on that, and we see the exact same error messages there. So let's take a look what we can get out of the revenue table this time. Okay, we run the query, and we get back the big ugly error message that we looked at in the PowerPoint slide, but let's take a look at it in some detail here. So it detected a logical consistency-based I/O error, invalid protection option. It occurred during a read of page 244. Okay, and in database ID 11 at this address or this offset. Okay, so it's trying to read page 244 in file 1, and something has gone severely wrong. Well, they even say severe here. It's a severe error, database integrity, and must be corrected immediately. Okay, well, let's take a look at what we got on our results page. Well, we did get rows back here. But as we page through, page all the way to the bottom, it looks like we got 595 rows back, and it gave us up to ID 601 as it was scanning through that table. Okay, well, let's take a look at what page 244 looks like. So I'm going to turn on the trace flag to show the output from DBCC page. I'm going to take a look at it here, and as we scan down, we actually get results back this time, unlike our previous example. And the first row of the page header here comes back looking like this, that I've copied and pasted up top here previously. And the first thing that jumps out at me, having looked at a lot of pages over time, is that the first byte is always 01 in SQL Server, at least I think since 2007 or so. But the first byte is 01, or is 02, but it should be 01. And then as we look through at the type, the second type should be 01 because it knows it's a data page, but it's not. And then as we go through, there's some other things in here that just don't look right to me. So I'm going to go take a look at a couple other pages for comparison. So I'm going to look at the page after and the page before, so 245 and 243. And when we run those, I've already copied the results back from both of them, and you can see them here. So if we look at this set of data in the header and compare it to this set and this set, you can see that it just doesn't look right. Okay, so something is definitely corrupt in the page header there, so how do we go about fixing it? Well, let's take a look at our indexes. See what we've got for indexes this time. So here, we only have indexes that cover the department ID and revenue columns. However, the non-clustered index, actually there is not a clustered index on this table this time, so let's take a look at what we can get back here. By using the non-clustered index, we still get back the ID, the department ID, and the revenue. And In this case, we get back 10,057 rows, far more than the 595 that we saw in the earlier query. Okay, so let's take a look again at select star from revenue. That gives us rows, same error we saw earlier, but it gives us rows up to 595 here, and the ID happens to be 601. Okay, so let's take a look using the order by ID descending. So we're going to start at the bottom of the table and scan up, looking for all the rows we can get back until corruption is encountered. And when we run that and page down to the very bottom of the results, we get back 9,450 rows with the ID of 615 being the last good one returned. Okay, so let's do some math here. We know that there's 10,057 rows from the non-clustered index. We know we can get back 595 of them before the corruption is encountered, and we know we can get back 9,450 after the corruption is encountered, so that gives us 12 missing rows. Okay, not so bad. We should be able to figure that out. So let's take a look at the IDs of the missing rows. So what I'm going to do is hit the non-clustered index called department ID and year here and give me all the IDs that are between 602 and 614. When we run it, here's the list, and I'm just going to copy all of those off and paste them in here and save them for later. As we go through 602, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, and 14. So it's a continuous set of numbers with the exception of 610. So let's look at corruption challenge, the data page for page 244 where the corruption is. This is the same thing we looked at a moment ago. And I'm going to take the results here. Wait, was that the same one? Let me check something here, make sure I did the right thing. Yep, 244 is the right one. So I'm going to save these results off, save results, and just a second here, put it on, I'm just going to throw it in my DB backups directory where I've got everything else from this, and I'm going to call it first save, and we'll come back and look at that in a minute. And then what I'm going to do is just leave that database alone for now, because I know what I can save out of it and I know what I can't. So I'm going to go look at the 2 days ago backup. I'm going to restore it to different file names, and it'll be known as Database Corruption Challenge 2 days ago. We're going to see what IDs we have in the table from 2 days ago that are between the 602 and 614 range, and it's showing us a total of 13 rows that are brought back. And we can see here that 610, the one that was missing in the other one, is indeed included here. Okay, so let's take a look at how many rows are in the table. When we look at how many rows are in the 2 days ago backup table, it's 10,054, which is not the original 10,057 that we're looking for. So let's just check the ones that we're looking for. So here's our list of the 12 rows that we're looking for. Can we get all 12 of those out of the 2 days ago backup? And I'm going to jump over to where those files are, first save and second save, and I'm going to use WinMerge as just a diff tool to compare the two of them. And when we look through it, yeah, there's some differences in the header, and we'll sort of skip through those because we know the header was corrupt in that case. And then we're going to go down and look at the actual row data. So we've got a different address that it's at, but that's fine at that point. But as we page through the actual rows in the data, or the rows in the diffs, and I'm just going to use the next diff option here. The only differences we're seeing are in the address there. The data in the pages are indeed the exact same until we get to slot 8, which happens to correspond with that row 610, I think it was. And then we continue on, and we can see that one record is different, and all the rest of the records are the same other than their addresses. And the offset table's not working from the first save because the header was corrupt there. So we can see from looking at the diff there that none of the data in the values of 602 through 614 is any different, and the only real difference besides the address of where things were sitting at in memory is that row 610 is gone. Okay, well that's good news because that means we can grab everything that's missing out of the 2-day-old backup and put it back in. So we're going to go back to the corruption challenge 2. So we're now in the corrupt database again. We're going to create a temporary table called revenue save that has all the same IDs like we did before. We're going to then insert into that table the first 595 rows out of the corrupt table. And we know we could pull those back previously without a problem. So we grab the first 595 rows, put them in the revenue save table. We now grab the last 9,450 rows, which is everything from the end of the table back up to where the corruption occurred. Then we insert into that table from the 2-day-ago backup the 12 rows that were missing. And then we could, at this point, run dbc check table with repair allow data loss like we did previously and fix it up. But instead, I'm going to truncate the table and then reinsert all of the data, because at this point I know we've copied off all of the data. Truncating the table removes all of the data pages, including the corrupt ones. I'm going to do check db and determine that the corruption is gone. We got no error messages back at that point, so it is indeed gone. And then I'm going to select what's in the revenue, sorry, the wrong table here, revenue table, to make sure, whoops, no, so that was the right one. I was going to select so the revenue table is empty at this point because of the truncate table. I'm going to then select out of the revenue save, and we can see at this point there are 10,057 rows, which is the number that we were looking for that came from the non-clustered index to begin with. So I'm going to insert into revenue, selecting from revenue save. But when we do that, SQL Server says, no, you can't do that because of the identity column. Okay, in the previous example, we did the identity insert, so we'll do the same thing here. Set identity insert for the table revenue to on. Insert everything in there from our save table, and then turn the identity insert off. Shows we get 10,057 rows. Okay, at this point, we're going to drop our save table. We're going to drop our 2-day-ago backup table. And we're going to select star from revenue, again confirming that everything's there. We've got 10,057 rows. And you know, I probably should have checked the corruption before deleting those other ones, but we're going to confirm that yes, indeed, the corruption is still gone. Our table is fixed. It's now repaired. Everything is back at a good state, and we recovered 100% of the data, and we know that we've recovered 100% of the data because of the diff that we did on the data page. I'm then going to run a backup so that if something else goes wrong, we're able to at least get back to this point here. Backup's complete, and the second corruption example has been completed and resolved at this point. Now, one of the things that comes up, the question that comes up oftentimes is, well, is that the only way to do it? Well, through the corruption challenges I've run it, I've been amazed. Each week as we've done the corruption challenge, I've seen different solutions submitted by different people on lots of different ways to solve it. So that was not the only way to solve this, but it was indeed a way to solve it without using any of the dirty hacks like DBCUC right page or things like that. Okay, any questions on the second corrupt database before we move on to the third one?
Can you run the DBCC CheckDB on a live production database, which has the active users on it? Or do you always recommend first taking a backup and putting that to a different location?
Okay, that's a great question. The question is, can you run the DBCC CheckDB on your live database with real live active users? And that really comes back to the traditional answer of it depends, but it depends on a lot of things. It depends on how much load you've got on your live database. It depends on how big the tables are. It depends on how long it takes for it to run. It depends on how much, how fast your temp DB is and whether you can have problems there. I mean, there's a number of things that go into it, but the optimal way to run the DBCC check DB is to run it on your live production database at a slow time if you can do it. However, if you can't do that because it just doesn't return or it takes too long because of the load, you can run it in a number of different ways, from an availability group failover server or on a backup and a restore environment, because of course you want to always be testing your backups. So you can do a backup and restore and test it there. But the best place to do it to determine is your live production database indeed not corrupt is on that server. Hopefully that answers the question.
That's fine. Let's see if we can get example 3 done.
Sorry, I didn't quite catch that. What was that?
That's all for now. Let's see if we can progress through example 3.
Okay, on to example 3. So example 3 is a little bit different. We're not going to be using that revenue table again, I don't think, here. So you've got a database, and at 2:53 p.m. a full backup was run. Following that, transaction log backup was run a minute later, and of course, in between each of these backups, there's a lot of things happening, updates, deletes, inserts, lots of things going on. At 3:01, you've got a transaction log backup. 3:12, you've then got another transaction log backup. And at 3:19, a catastrophic failure occurs, causing the operating system running SQL Server to reboot. Okay, we could blame this on a power surge or something, or maybe it was just someone who accidentally bumped the power cord. I kind of like the power surge idea, so I don't get blamed for kicking the power cord, but in reality, I'm not going to be anywhere near the cord. So, what you've got is you've got a database that, in this case, the last backup that occurred was a transaction log backup at 3:12, and at 3:19, the system rebooted. After the reboot, all of the other databases on the SQL Server recovered just fine. However, the one called Corruption Challenge 3 would not come online. Ooh, that's always trouble. So after examining the SQL Server data directory, it was discovered that the MDF file for this database was gone. The only thing that remained in the SQL Server was the LDF file and previous backups for the database. So the database is showing as being in a recovery pending state. All right, bad news at this point with the MDF file being missing. If this did occur, I would be really suspicious of other things that might be really wrong with this database because of the file system or something like that. But let's take a look at this. What we see is Corruption Challenge 3 shows a recovery pending state. So you want to think as we go through it, what would I do first? And hopefully everyone's thinking that. If something goes wrong, how can I undo what I try? And what can I do to determine what is corrupt? And what can I do to recover everything to the best of my abilities? So what can I, if something, well, to prevent from making anything worse, what I'm going to do is start by making a copy of the files, which I prepared earlier, somewhere here. We have Corruption Challenge 3, we have the full backup that occurred earlier. Corruption Challenge 3, we have the several transaction log file backups that were mentioned. We have occurred before all the changes occurred. Okay, BAK file comes back good, no errors at this point. I'm going to then alter the database and set it offline. And let me click over here and just refresh the database list so we can see this. We can now see Corruption Challenge 3 is in an offline state. I'm then going to take the LDF file that we copied off of the server after it rebooted. Hit Control-C to copy it. I'm then going to paste it in my SQL data directory, paste over and replace the LDF file that came from the backup. And I did that with a paste instead of a delete and a paste because when you paste over it, it keeps the permissions the same as it was before. And I'm going to delete the MDF file, simulating getting back to the point of the recovery pending state on this database. Okay, so I'm going to jump back over to SQL Server. I'm going to set corruption challenge 3 database back online, and it gives me some error messages. Unable to open the physical file for corruption challenge 3.mdf. Okay, well, the file's not there, so we kind of expect that we wouldn't be able to find that. So it's just telling us what we already know, and it leaves us in the recovery pending state. So now we're back to the exact state that was reproduced after the wacky reboot on the corrupt server. Okay, so what we've got at this point, we know we've got a full BAK file. We know we've got all the log files up to, let me switch back to the PowerPoint slide for a moment, 254, 301, and 312. So we have 3 transaction log files, and then we have missing transactions that we want to recover between 312 and 319. So the way we're going to get those back is we're going to attempt a tail of the log backup on this database that's in this recovery pending state that's only half there, or maybe not even half there. But when we do the tail of the log backup, a log backup this way, what it's going to do is it's going to look into the log file that we just pasted in there, copy out everything it can, and it's going to save it to this challenge-tail.bak file, and we need to use with the no truncate. We run that. We have successfully pulled the backup out of that log file without the MDF file being there, and we're able to now save off all of those transactions and be able to replay them if all of our other backups are not corrupt. Okay, so let's give that a try. So what we're going to do is we're going to go back to, I just copied and pasted the exact same restore statement that I used at the very top of the earlier BAK file, the full BAK. So we've now restored, and I'm going to refresh over here and see that it's left in the restoring mode here because we've used the no recovery option. And what the no recovery option is doing is it's saying do the restore, but leave the database in a state that additional log files can be restored or played back to it. So let's take a look here. What if we were to just take our tail backup and do a restore on top of that? Well, if we try that, what happens is it says the log begins at this LSN, which is too recent. So it's telling us we have the wrong order at that point. So what we're going to do is start at the beginning with the first transaction log backup that we had after the full backup. We're going to restore that with no recovery. We're going to do the next 2. Those come back fine. And now, if there was nothing missing along the way, we're going to restore the tail of the log backup, or that we copied out of the LDF file, and it worked. We were able to get back to this point in time, eliminating the corruption, being able to get the database back online 100% from the backups that we were given, plus the tail of the log backup file that we were able to extract from only the LDF log file. We now run the with recovery, which does the final restore and puts it in a state it can be used. Over here, I'm going to refresh, and then I'm going to use corruption challenge 3 and try attempting select star from the history table, and we get a bunch of information here. But what I know, independent of what data is here, I know that we've done a complete restore because I was able to take this tail of the log backup from the LDF file, and it was able to be recovered in the right log sequence number after these previous ones. We know that nothing was missing at that point because of that, and we know that the database called Corruption Challenge 3 is back intact and functional at this point. So at this point, we have completely restored Corruption Challenge 3. Any questions on that before we move into?
No, we did have a comment. This did happen to someone when the CN went out. They lost the MDF, but still had the LDF.
Oh, so a similar thing occurred because of SAN failure. Is that?
Yes.
And I guess that would be pretty common, because the right thing to do is to have your again, this is my just my desktop server here, but it would be, you want to have your MDF files on a different drive than your LDF files, and if you lost one drive, yeah, it's possible that the MDF file would be gone at that point. So, yeah. Okay, so next, I was told I could go over a little bit here. So I've got a fourth challenge I'm going to go through very quickly. This is one that was backed up on SQL Server 2008 R2. The database is named Corruption Challenge 4. It was created and backed up on SQL Server R2. Here's what we know. Everything was just fine, and all of a sudden, users started reporting the following error when selecting from the database. Attempt to fetch a logical page failed. Okay, so let's go through and take a look at that one in a couple minutes here real quick. Now, this example, I just wanted to give a disclaimer. Through the Database Corruption Challenge contest, one of the participants, Patrick Flynn, submitted this answer, and I thought it was a really awesome solution that was different than the way I had solved it, so I'm going to go through and show what he did here. So to start with, we're going to restore the Corrupt Challenge 4. Take a minute to restore here, and it's fully restored, and then we're going to take a look at it. So take a look at Challenge 4. We're going to first just see how many objects we have in the database, and there are 5. I'm then going to try, actually I didn't try, let me refresh this over here real quick. So there's Corruption Challenge 4, and I'm going to try, I forgot to do this here, select star from customers. Okay, there's where the failure is occurring. Select star from orders. In the orders table, no messages. The orders table seems okay. So the problem is within the customers table. Now, normally I would run a DBC check DB to get as much detail as I could at this point, but when I ran it on this particular database with this type of corruption, it crashed after 15 minutes and returned that there were a bunch of errors. So rather than waiting the 15 minutes, we'll assume that happened. So what I'm going to try and do then is the customers table is corrupt. I'm going to try and copy what we can out of it. But I'm going to create a table called customer copy. And you get a message that says, hey, that is forbidden, not allowed. Computer says no. Well, that's because of 2 ugly triggers that I put on the database that prevented people from creating or dropping tables. So to start with, I'm going to disable those triggers. I'm going to then create this table to store some information off to. And then I'm going to see what we can get out of the indexes. So similar to before, we're going to grab from the non-clustered indexes. And when we run that, we get 511,000 rows. Okay, so now what we're going to do is make a second copy of the data, or sorry, a second table to store information in, because we know we didn't get all the data at that point. We're then going to, and this is where it gets interesting. So this solution is going to use the dbcc end command to list all of the pages that are in that table. Each of the dbcc page commands, and then it's going to select the value out of the data into dbcc page and delete that page, close the cursor, and then let's take a look at what we've got in that table there. Okay, I wanted to run through that a little bit and get it running because this part here takes about a minute to run, but it's sort of a non-standard approach where it's ripping through all of the pages it can with dbcc page for this table, and it's reading all of the data manually out of it that it can, and it's storing all that information off with its offset length and all the information so we can then take it to the next step, which will be to actually take that data and convert it into something that then can then be reinserted back into our corrupt table. And should be about 20 seconds more here. So right here is where it's going to stop. So after that runs, and when it's done here in a moment, we'll just take a look at what we get back from the DBCC data table, or temp table. And when we look at that, if you've used the DBCC page, you'll recognize the format of a lot of this, but it's not exactly really readable or usable at this point. Oh, and we did get a couple errors along there about you can't drop tables because I had a script that would drop the tables if we ran it a second time. So then what it's going to do, so based off the results, we can see that all the data is here, but it's not exactly human recognizable in any way. So it's going to use this common table expression to translate it based off of the substring and a number of different positions of where the data starts. Where did it go? And it's going to select all of that with some reformatting here into a table called temp customer data, with picking out all of the individual data elements with that. So we run that CTE. Again, I don't have time to explain all of the details on it right now, but that's available on my website if you want to look it up and find it. Then we're going to look at what we've got in that temp customer data table. So the first few columns are similar to what we got before, but we now have string values in here that are showing we can actually start to see some of the data that's in this table and possibly in a way that it can be used. So next, we need this function to create the hex string to var binary. So I'm just going to create this function here. And that function is going to get used multiple times in this next common table expression that goes through and picks out each of the individual values and inserts them into this customer copy table. So I'm going to comment out that insert statement for just a moment and run this. And that we can see as this runs, it takes a minute to run, and we're going to end up with all of the rows that we're looking for. Actually, I'm just going to stop it now and actually do the insert statement here so it puts it into the table. And this will take a moment to run, but when it's done, we'll take a look at it and we'll see that there was 511,000 rows, 511,700 rows inserted. And let's look at what's in that table now. There are all of the names, middle names, and last names that were missing from there. Now what we're going to do is compare what was the data extracted from the non-clustered index. So we're going to compare customer copy 1 and customer copy 2 and select how many match. And all of them match at this point, so there's no rows missing. If we look, we can see, because nothing's returned here, that all of the names, the first name and the last names match, but where it's missing is that some of the middle names don't match in this case. So we're going to use, so what we're going to do now is put the data back into the original table. So we're going to use corruption challenge 4. We're going to drop the constraint, foreign key constraint, make inserting easier. We're going to set identity insert on like we've done a bunch of times so far, truncate the table just to get rid of all the corruption, insert everything from customer copy 1, set identity insert off. We run that, it dumps all the corrupt pages, it reinserts all of the rows we're looking for. We can now run checkdb and see that our database is indeed clean. It didn't time out after 15 minutes like it would have in the beginning. And we're going to clean up. We're going to put back some of the constraints that were taken away. We're going to use the corruption challenge. We're just going to use the database. We're going to then drop all the temporary tables that we used along the way and the function that was created. Re-enable the nasty triggers that were preventing people from adding or removing tables. And then we're going to check to make sure our object count is the same 5 objects in the database we had originally. And we're going to select out of the customers table the 2 rows that where the corruption occurred and see that my name, which I put in on the corrupt row. If you got that result back, then you've got the right data here. So that example was sort of a quick one to run through, but we were able to eliminate all the corruption, and actually, based off the example that was provided by Patrick, we were able to scan through all of the output from DBCC page and reconstruct everything that needed to go back into that table that may have been corrupt. Okay, so on to the summary page, and then we'll have questions. So at this point, the thing you want to keep in mind is detecting corruption. There's a lot of different ways to get it, or to be able to find out about it. Once you start tracking it to find out what's gone bad, you want to make sure you understand what exactly is bad or missing. And then before fixing or removing corruption, you always want to make sure that you have a way to get back to a known state that you're in right now, so you at least don't do any harm or don't make it any worse. And then you go through and remove the corruption. And if anyone's interested in any more examples, Week 5 Corruption Challenge is currently running on my website. And you can take a look at that, or you can contact me through LinkedIn or email or Twitter. That's it. I'd like to open it up and see if there's any questions at this point.
Hey Steve, on your website, do you have the scripts that you ran through for challenges weeks 1 through 4 and the solutions?
Yes, so the challenges for weeks 1 through 4 and these solutions plus some other solutions are posted on my website. You can, and that's the thing with the solutions, there's usually more than one way to solve it. So most of these have more than one solution, and in fact some of them have 2 or 3 different solutions as to how they're solved. And the way the corruption challenge works is I post a challenge with the corrupt database that people can download. They've usually got between 2 to 4 days to figure it out and get it solved and prove to me that they solved it. And then the best solutions and the more interesting solutions get posted on my site.
So do you keep the corrupted database available so people could work through that at a later time for the other challenges?
Yes, good question. So I can show you that real quick here.
These are some of the questions that we're getting.
Yep. Okay, so if you go to my website, like right now at the top of it, Week 5 Corruption Challenge is running. You just read the details there and click through and see the description. Check out the details here. And then here's the exact details of what's going on and the exact error message that's shown for Challenge 5. But if you want to find out about the previous ones, there's this menu item up top called SQL Server Health. Go to Database Corruption Challenge, and you can look through to Week 1, Week 2, Week 3, Week 4, and Week 5, and this will just continue to grow through the rest of the competition there. So, and you can go and find the examples on all of the. If we want to look at Week 1 here, actually Week 1 I didn't document as well as the other weeks, so let's look at Week 2. Whoops. Week 2. We can see here's the example that we saw before. You can click through to the details, and there's the error messages that we were seeing, and you can scroll down and download the actual corrupt database files and try it yourself at home.
That's great.
So the corruption challenge is just something I built as a fun way to sort of practice and keep sharp on all of the ways to deal with and fix corrupt databases. And each week there's been typically between about 20 to 40 people competing, and it's just been a lot of fun.
I think that's basically it for the questions. I'll send you the question log, though, to see if there's anything else that I missed. Great presentation. The recording will be uploaded to our website as well as the slide deck, and then you can go to Steve's website here to get the scripts and the databases for the different corruptions to play with that. Again, thank you, Steve. This was very informative, in that the last one was a bit quick and overwhelming, the solution. That'd be good to go back and really look at that a little slower. But really, you got a lot of great comments from this, and thank you so much for providing us with the presentation.
Yep, and happy to help. And again, sorry I went through the last one so fast, but you can check it out on my website and go through it at your own speed if you want to, and try it out on your own.
That's great. Thanks again.
All right.